In this video, I'll be working through the question you see on the screen here. It's from the 2024 Leaving Cert exam Honours Level Paper 1. If you're looking for a different question from that paper, you should be able to find a playlist in the description below. I'll be doing all this on a whiteboard, hopefully so it's similar to what you're used to your teacher doing. But we're not in a classroom, we're on YouTube, so take advantage, pause, rewind, stop, rewatch, all those things you can do on YouTube. If you find this video useful or any of my videos, I would greatly appreciate a like, a subscribe, and what helps most is sharing it with a friend that's doing the Leaving Cert or one that's going to do it next year. Question 7 starts off with a simple tax question. They tell us someone, Fayad, has a gross salary of 54,000. They pay tax on the first 40,000 at 20%, and the rest of the money they pay it at 40%. So let's just say rest of the money. And they have an annual tax credit of 1,700, right down here, 1,775. Remember how we do tax. We work out the tax first, your gross tax. We make a guess at the tax. Well, we work out what the tax would be without deductions, and then we just take the deductions away. That's it. So how much tax is this person pay? They pay 20% of 40,000, and let's rub out rest here. They pay 14,000. The rest of this, take 40 away from it. We have 14,000 left at 40%. So what's the tax on that? That's 40,000 multiplied by 20%, and that's equal, I guess, 8,000. And then 14,000 multiplied by 40%, and that's equal, let me check my notes on that one, 5,600. Add these together, this person would owe 13,600 in taxes, except they have tax credits. So we take away 1,775, and again, I'll check my notes instead of doing simple maths like that. 11,825 would be their total tax bill. I'm sorry, they didn't ask that, did they? Yeah, work out their annual pay. So how much do they take home? Their paycheck says this, but they have to pay the government this. So what's left? We take 54,000 minus 11,825, and we're left with 38,175. That's the answer. Okay, in part B, they tell us Fayad and her partner take out a 25-year mortgage at a monthly interest rate of 0.279%, and they make equal monthly payments of 1,647.75 at the end of each month. They make the first payment exactly 1 month after taking out the mortgage. Write down the present value of each of their first 3 months, 3 monthly repayments at the time they were taking the mortgage. And they tell us don't bother working out any of the powers. Leave it as a fraction. So to get present value, you don't have to remember it. It's in your formula book, page 30. Present value is equal to the final value divided by 1 plus I to the power of t. So in this case, the present value of 1 month, t is going to be how much time has passed. So 1 month, 2 month, 3 month. They asked for all of those. They asked for 1, 2 and 3. I is the interest rate. Again, we're dealing in monthly ones. So there's the interest rate here. Remember, this is percentage. I never wrote that in. So that's equal to 0.00279. Be careful about that. Otherwise you'll get a way too big of a number. So the present value after let's do it here, 1, 2 months and 3 months. The present value after 1 month is 1,647.75 divided by 1 plus this. We can do that in our head, 1 plus 0.0279, and all of that is to the power of 1. After 2 months, we just get nearly the exact same thing. 75 over 1.00279 to the power of 2, and same here to the power of 3. Now, a bit of editing saved me having dead air there. This is the answer to part 1. They wanted left as a fraction and not to bother multiplying out the powers. So this is exactly what they asked for. On to part 2, they asked you to work out the amount of money that Fayed and her partner borrowed. So we know how much they pay back every month. Remember, this is a 25-year, so that's 25 times 12 is 250, yeah, 300 months. So that's the term. So we could find out how much they end up paying, multiply this by 300, but that's not what they're asking. They're asking how much did they borrow. Now, this question, with this hint here, this is how they did part 1. They're trying to lead you into a way to answer this, but I do want to point out a more normal way to answer this question would be, there's a formula in your book here, I'll write it out here. A being the final amount you pay in your mortgage. This is the amortization and mortgages and loans things called. So A is equal to P. This is how much they borrowed. This would be how much they borrowed times I, 1 plus I times power of T. This would be 300 over 1 plus I power of T minus 1. If you rearrange this and solve P, so you know A's here, you know I's up here, you know T, you know all of this. You can rearrange this and find P, and that would answer this question. So I just want to point out that's one way to do this. How they seem to be suggesting you answer it is to look at these 3 terms as a sequence. This continues on, 300 of these there are. This is the first month, the second month, the third month. So if we think of this as a sequence, a geometric sequence, it's the first month is A, well here, let me just write here, A is equal to this guy. Put an A above here. This term here would be A. What would OR be? What's changing every month? OR would equal 1 over 1.00279. That would be OR there. And if you want to know how much they borrowed, well, it's their present value. This is the present value after each month. How much the money's worth now. And by definition, that is what they would have borrowed. How much this money is worth this month. How much this money is worth this month. Add it all together, it should tell you how much they borrowed. So if you use the sum of a geometric series formula, let me get it here. The Sn is equal to A multiplied by 1 minus Rn all over 1 minus R. If you fill everything into this formula, remember N is 300 of these terms. A is this whole thing here. R is this term here. And yeah, that's it. N again is 300. If we fill, I won't do it here, I don't have much room, and it's just big and messy, just like doing this one would have been. If you fill all that in, you would get a answer of, there is there, 335,496. At least I hope you do. There's no marking scheme out yet, so I can't double check that. Okay, in part C, Fayed puts his money into a savings account and leaves it there for a number of years. And this formula here tells you how much money is in his account after 1 year, 10 years, 100 years, whatever. We don't really need this, but it's often handy to know what a function looks like. So look, maybe you don't know, but if you do know, just draw a sketch of a exponential function. The number here in front of it is actually the y-intercept. That's 5,000. And an exponential function looks like this. It goes slowly up and then fast up. Looks like that roughly. That's not really necessary for this question, but we'll go ahead and use it. Okay, so they ask you to use differentiation to find out how much the money is increasing. Basically the slope. What's the rate of change? What's the rate of increase of his money after 3.5 years? To go to the picture, that just means after 3.5 years, what's the gradient? What's the slope? That's what they're asking. So we'll just go ahead and differentiate the derivative of t. It's not hard differentiation. It's in your book. Well, first of all, the 5,000 is left alone. Differentiating e to the power of something, e to the power of something multiplied by t. It just means this number comes down front and multiplies 0.04, and then we leave it alone. Again, this is just all in your tables book. Shouldn't be too much trouble. This multiplied by that is 200 e to the 0.04t, and that's the derivative. But they asked us for the value of the derivative after 3.5 years. So 3.5 goes in here. That's 200 multiplied by e to the power 0.04 times 3.5. Put all that into a calculator, and we get, let me just double check here, we get 230. Do they want the nearest euro? Yeah, okay, nearest euro, 230. So that's how much your money is growing at this exact moment in 3.5 years. Okay, part 2, they ask you to use integration this time to find the average amount of money in your account over the first 5 years. So again, we'll go to the graph here. I'll rub that out, and let's rub the line out as well. We'll say here's 5, and over 5 years, find the average height basically. So it was low, it was low, it was low. Maybe the average height is here somewhere. But how do we do it? There's a formula. There's involving integration. Let's write it over here somewhere, and I'll explain it up there then. So the formula is, what's this, ft in this case. The integral of ft between two things, in this case 0 and 5, then divide that answer by the length of this, the length between 0 and 5. So divide it by 5 minus 0, or 5. And you can think of that as breaking this into 5 sections. The height of each of them, and then averaging it by dividing by 5. Now that's not quite right, because how do you get the average of each of them? You'd have to do this again and break this into 5 sections. So really we're breaking it into millions of sections. And while it looks like we're dividing by 5, we're actually dividing by millions through this integration. Billions, infinite. So we're getting a good average. Yeah, I'll say something else about that at the end. But let's just do this over here. 1 over 5 multiplied by the integral of this guy here. That's 5,000 e to the 0.04t dt. Now we can do a lot of this out front. 5,000 will come out, and we'll just be left with 1,000. 5 is a constant. It can just come out, divide by 5, we get 1,000. The integral of e to the at, or ax is in your book really, is just going to answer as 1 over whatever this number here is, which is 0.04, and then we leave it alone, e to the power 0.04t. That's the integral, and we evaluate all this between 0 and 5. Let me rub this out, and I should be able to fit all of this in. Okay, if you put 5 in here, yeah, if we divide this into the 1,000, we'd get 25,000. And putting 5 into this would be e to the power 0.2. And putting 0 in would be e to the power 0, which is just 1. So, or taking away just 1. We get that. Put all that into a calculator, and you get 5,533. Again, probably to the nearest, nearest euro there. One thing to know here: if you get an answer putting all this in, there's lots of places to make mistakes here. Check your answer makes sense. I'm trying to find the average amount of money in my account. I put 5,000 in. I earned interest, 230 a year after 3.5 years point. So does it make sense? That number makes sense. If I got like 1 million as an answer, that wouldn't make sense. If I got 100 as an answer, it wouldn't make sense. So this is 5,000. After 5 years, I don't know, it's probably at 6,500. What's the average height in there? Yeah, that sounds about right to me. For part 3, I should probably rub out the board, but I think I can explain it with just a small bit of area here. They ask you to work out the annual rate of return, the AER. That's the actual rate of return. And if we look up a continuous compounding formula, it's all in your book here, a lot of this. You'll get a formula like this, and it'll tell you whatever number is here is the what do they phrase it? The nominal, which I don't like that as a word. It's used somewhere else for something else. The nominal interest rate, and that's 4%. But that's imagining, oh, you get 4% a year. But what's really happening is every day, every minute probably, you're actually earning interest, and it's adding back up. And what is that? What is that real amount? Now, luckily, the book gives you a formula for that. It tells you whatever's here, whatever this nominal number is. What's the letters they use for it? Or equals 0.04. That's 4%. Whatever the nominal number is, the interest rate, the AER, what they call it the actual. The actual interest rate is just equal to e to the power of 0.04 minus 1. And if you put that into a calculator, you'll just get 0.04. Let me just check my notes. 0.408, which is the same as 4.08%. Another way to think of it is, that's the right answer. First of all, that's one way to do it. Another way to do it is simply to find out how much money was in your account after 1 year. I think I wrote these numbers down somewhere. No, I didn't. So quick edit. I got the numbers. After 1 year, at the start, you had 5,000. After 1 year, if you just put 1 in, you'd have 5,204.05. What's the percent change between that? It's 4.08%. That gets you the answer. You could stay going though if you want. After 2 years, 5,116. The difference between this and this is again 4.08%. Another way to think of it is if you rewrite this, 5,000 goes in, e to the power of 0.04 is 1.0408 to the power of t. You could rewrite it as this, and that's your actual interest rate there, or 104% is there. I don't think I explained that too well. I must admit, I work in finance and I work in interest, and I do interest all the time, and I never do it like the Leaving Cert. I do it much more simply. I think of it much more like this formula here actually all the time. So apologies if I probably taught it bad, because I've learned bad habits over the years. But hopefully I answered the questions. If I didn't, ask some questions in the comments. I'll do my best to answer, or hopefully someone else might even help answering. Anyway, that's it for question 7. Thanks for watching and have a great day.